Hey folks, thanks for sticking around to the end of the day. I hope you are appropriately caffeinated, ready for this talk. Awesome. So today I'm going to talk about how you can think about making your data discoverable and governable in a data platform where there are so many different sources and types of data sets from raw to curated and so on and so forth. And I'll be sharing some tips that I picked up over the course of building this out and enabling discovery in our organization. So my name is Sherin. I'm currently a software engineer at Chime. We are a fintech company based in San Francisco. Previously, I spent some time at Netflix, Lyft, Twitter, and Google. I am what they call a Sunday artist. I love to paint in my free time. Can anyone tell me what they see in this image? Take a wild guess. Everything, yes. These are like all the data tools and technologies that existed in 2012. Fast forward a decade, this is the number of tools and technologies in the data space that existed in 2021. There are so many, I literally cannot read the names of any of these. The bottom line is data processing and data analytics and data curation has become super easy over the last decade, but this has led to a different problem, that of an abundance of data or too much data. And because of this abundance, finding trustable source of truth data sets has become really challenging. Good, useful data is often hidden amongst duplicates, inaccurate, or ambiguous data. And when you're looking for source of truth, ambiguity is bad. I read this phrase somewhere, when in doubt, you can't be wrong. And this stuck with me. When you're looking for trustable data, you just cannot afford to be wrong. Does anyone here know what Conway's law is? Have you heard of Conway's law at all? So Conway's law says that architectures often mirror communication structures in an organization. So basically, companies that adopt a microservices architecture typically have like separate siloed organizations and so on and so forth. At a typical software company, product engineering is a separate organization from data science or data analytics or anybody who's using data. Analysts and data scientists are consumers of data, while product engineering are producers of data. That's where they originate data through events and logs and databases. Producers don't know what consumers need, and consumers often don't know what producers have. While the data engineer is stuck in the middle, they are neither the producer nor consumer, and they are trying to bridge the gap. And we need a way to make these groups talk to each other, which brings me to the first tip of the day. Bring everybody to the same water cooler. If you remember those old-timey office pictures, there are these water coolers at different corners of the office where people congregate, exchange gossip, like gossip, what did you do over the weekend, that sort of stuff. We need something like that in the digital world to bring everybody on the same page and exchange information and context and tribal knowledge. When we set out to find something like this for our organization, we had some requirements. We wanted to onboard a data catalog that can be used for many different types of users, from PMs and engineers and executives, everybody. And it needed to support a range of data artifacts, tables and pipelines, people, roles, everything. And this data catalog also needed to surface the relationships between data, how information travels through the organization, so that you can get a full picture of all the connected components, everything in a data platform. Moreover, context is often, it lives in different places. There is context in Slack, there are documents, there are code comments, there are just in somebody's head. And we needed to collect everything in one place and search and retrieve by relevance. A place where producers can put context and consumers can find what they need. And we decided to adopt Data Hub, which is an open source product it's an open source metadata platform. that enables data discovery, data observability, federated governance. Acral Data is a company that provides a managed version, but many companies are using an open source, the open source version of it. And under the hood, it's essentially a metadata graph. It is a graph of relationships between people and data and code and everything that you can think of. And on top of that layer, discovery, observability, and governance is applied. This is what it kind of looks like. So when we go to the landing page, we have data organized by domains, by different types, data sets, tables, and so on. And you can do search by relevance. You can, once you find the data, you find documentation about it, full context about the data sets. And lineage is my favorite feature, especially the column level lineage. We used to have so many issues where someone would change the column type or just delete a column or so on, and the repercussions could be felt like many hops away. And this lineage gives us a way to run an impact analysis and make sure that producers are not breaking things under the hood. The second tip is choose a common data language. Basically, a platform-agnostic way to codify a data model, a schema definition language. At Chime, we use protocol buffer schemas pretty heavily, and not just for serializing data on the wire or for serialization and deserialization. We also use it as a representation of a data model, even for files that are coming in, even to represent the data format of each row in a file that are ingested by an Airflow DAG, perhaps. We also use it for defining service, like service APIs and request response and so on and so forth. But the more important thing is tip number 3, which is use schema for more than just schema. And what do I mean by that? So a very cool thing about declaring schema in code is all of this extra surface area that you get for free to enhance the capabilities of your schema, to add documentation, to add tags, and so on and so forth. In protocol buffer, they introduced something called as message and field level options. And these message and field level options can be used as annotations to add extra metadata about a schema. So here you can see we are using message level annotations to define a type of a profile event, the team that it belongs to. And we are also using the field level annotations to define classifications that I'll later discuss how we use it for governance. And most importantly, documentation. Adding code comments is the most natural way for engineers to add documentation. So schema in code provides that surface area to do all of these cool stuff. And the best part about these annotations and all of this extra metadata, it's not really sent on wire. So it doesn't increase the size of your payload on the wire. Rather, it's there in code for you to access if you need any of this metadata. And to me, the most interesting part about this is it opens up the possibility to use protocol buffer schemas as a declarative language. Point number 4, keep the logical and the physical together. Now, in any organization, raw data usually originates at the ground floor, or what I call the physical layer. And this data can be in the form of structured or unstructured events and logs and database entries, change data capture events, unstructured documents, so many different things. Usually it's not used as it is. There is often some amount of ETL process, like post-processing, a data engineer, somebody curates it, processes it using ETL workflows, generates fact tables, then generates curated data. And it is often this curated data that is used for driving business insights for many different things. Mostly marketing analysts, PMs, or executives are using this business insights for funnel analysis, many different things, and they are far removed from the raw data, or they are really far removed from the many different layers that are involved in getting it to the insights phase. But they are not fully isolated from it. If problems originate at the raw layer, at the physical layer, or as I call it, it can manifest itself in terms of issues in your insights. For example, if there is a data quality issue, let's say there is a field that was just dropped which impacted your revenue numbers, it's very hard to see whether your revenue numbers just dropped organically or was it a data issue. And this is why it's important to have visibility into what's going on everywhere, even at your physical layer, to get a 360-degree view to understand the impact of things. Keep the logical and the physical together. Bring engineers, PMs, analysts, business insights folks, everybody to the same tool. Engineers can add context, add assertions, data quality checks to the data they produce or curate, and technical issues at the physical layer can be easily bubbled up to the logical layers. And this is where the graph, the lineage graph, comes in handy. We use the lineage graph to essentially bubble up any assertion failures and so on to show whether a dashboard might be impacted, for example. And visibility increases when everybody is communicating at the same place. Point number 5, keep the logical and the physical separate. I can see that I have already contradicted myself, but please hear me out. Data governance is a gnarly problem. Rules of data retention and handling can vary so much based on where the data lives. Moreover, a data can exist in many different forms, as table, as event in a stream, in a data lake, as a dashboard. And the most challenging aspect of governance is applying rules and policies consistently across all the forms in which data exists. Also, rules and policies may keep changing. There is a famous saying that all problems in computer science can be solved with one more level of indirection. Every data entity should have a logical model defined in a schema form, in code, something like protocol buffer, and you can specify data classification or data governance rules on top of the schema using annotations. And now rules and policies can be defined separately in a central glossary, and rule orchestration can happen at the platform level, essentially 3 levels of indirection. And this grants the flexibility and decentralizes the governance process. Let me give you an example. Data producers know their data the best. They know what they are sending. They know how to classify it. But they shouldn't be concerned about who has access to what, the governance aspect of it. So what we have done, we have empowered our users, our producers, to tell us what the data means. Like, is it a full name? Is it a SSN? And just like add those classifications at the field level. Separately, by adding one more level of indirection, another team, the security and privacy team, defines how these classifications map to different, whether full name is sensitive or confidential. These determinations are made separately. Also, the rules of handling it. Should sensitive data be retained for more than 30 days, or should it be masked? These rules also exist separately. In a glossary, a mapping can be created between what maps personal info to sensitive, for example, and policies can be mapped to rules. And rules can even be broken down by platforms. This way, each platform can implement their own rule orchestrator and refer to the glossary for policies and the schema for the classification to determine how to handle data. Using this level of indirection, we are separating the logical, that is the rules and policy definitions, from the physical manifestation, that is applying these policies at the platform and infrastructure level. Point number 3, crowdsource metadata ingestion. When we started working on this data discovery and governance project, initially the data infrastructure team was essentially like pulling data, and we have many different systems. We use Airflow, we have for stream processing, we have Kinesis, for batch processing, we have Spark, we have a lot of custom declarative frameworks built on top of these things even. So, and these all reside in different teams. The ML platform is a different team, so many different things. And initially we were pulling all of this context from these different teams. And this wasn't scaling. And moreover, we were trying to understand what context is useful, what is the metadata that we should be collecting. But data platform or infrastructure, we are neither the producers nor consumers of data. We are just the people providing the shovel or the pipelines. To streamline things, we deployed something like a squad model. So instead of doing it within the data infrastructure team, we put together like a squad or a group of data stewards with representatives from different teams. So now we have representation from ML platform, from BI, security, data engineering. And each member in the squad brings special skill sets and perspectives as to what metadata needs to be collected, how must governance rules be applied, for example. And since then, we have been able to ramp up our impact. Metadata ingestion should not be data platform's responsibility alone. And design, the other principle that we really went by is to design metadata ingestion to be as close to the source as possible. So we went from a pull-based model where data infrastructure was pulling context to a push-based model. Think log and metric collection. Even metadata needs to be collected at the source on an ongoing basis. Our squad built a central metadata collection API, which is a wrapper over Data Hub's own APIs. And now with this team, we are building metadata extractors, which essentially convert the source model into a metadata model that is understood by Data Hub. Now, these metadata extractors are crowdsourced. They live in the platform that is supplying the metadata extractor, and it is continuously pushing this metadata to Data Hub, and we don't have to do anything. It's just continuously being pushed and kept up to date. Point number 7, everything must have an owner. And this is an easy one, but still very, very hard to get right. No owners, no accountability. And as you are thinking about cataloging data sets, make sure to assign ownership from the get-go. Also consider different types of ownerships. A technical owner might be the producer or curator of a data set and responsible for managing incidents and so on. A business owner might be responsible for appropriately cataloging, contextualizing, and asserting on key SLAs for the data set. Point number 8, meet data consumers where they are. One thing we noticed was it's very hard for people to hop from one tool to another. We already use so many tools. We have Slack, we have Google Docs, Notion, so many different things. And if users have to hop from one tool to another to find context, inertia sets in and they end up just going to Slack to find answers. Rather, we wanted to bring context to the consumers. To help with that, we use a Chrome plugin, which was built by Data Hub, the Acryl who manages Data Hub for us. This plugin, essentially, we currently have a plugin for Looker, and this brings all the context about a data set that a BI person is looking at into their own tool. So now they don't have to go to a separate tool. Everything is available in a Chrome plugin. Tip number 9, shift left. Shift left is a generic term used across the industry to define an approach where responsibilities are shifted to earlier in a software development lifecycle. This is commonly heard in reference to software testing, where quality assurance is moved to earlier in the pipeline. We wanted to use a similar approach by moving cataloging responsibilities to earlier in a data lifecycle, which means giving cataloging responsibility to producers. I don't know if you realize this but I'm a big fan of schemas and schema annotations. And as I mentioned earlier in the governance example, at Chime we use protocol buffer schemas and schema annotations pretty heavily. And schemas are a gold mine of information. We have context in comments, we have classifications, we have a lot of ways people are using annotations. To catalog, what we did was we used protocol buffer SDK. We built a protocol buffer SDK to essentially ingest all of these comments, scrape comments from schemas, and push that as documentation to Data Hub. Also, the annotations are converted into tags or glossaries or domains that adds like special indexing on top of this information to make search and organization easy. With this ingested into Data Hub, now we can search across the entire ecosystem to find what we need. Moreover, we can slice and dice by tags, we can organize by tags, and so on. I saved the best one for the last, which is data contracts. This is a hot topic that's been, at least it's been showing up very frequently on my LinkedIn, and it has been, there's been a lot of conversation happening around data contracts over the last few months. But what is data contracts? To explain that first, let me bring you back to the first slide where we established why discovery and governance is hard. The root of most of our problems is a disconnect between producers and consumers. Data contract adds a formal agreement between producers and consumers where one didn't exist before. Think SLAs. In this world, consumers add assertions and producers own accountability for any assertion failures. Throughout this presentation, we already talked about a few key components that, when put together, can form a data contract. First is schema, and this is the bread and butter. For any SLA, a basic level of validation of the data model is required. But that is not sufficient. You also need semantic validation. This is where data quality checks come into play. There are many data quality tools today, like Great Expectations, Anomalo, many different things. We are using the one within Data Hub. We have also built our own custom data quality checks using Airflow tags, and that live very close to the transformation logic. But we are surfacing it via Data Hub. This way, users, whenever they're looking at a data set, they know whether there were semantic failures, whether there were any like data quality check failures. But whatever tool you pick, think about how you can streamline assertions and contract creation. Consider a surface for declaring schema and semantic assertions. The other component of contract is accountability. And lineage is a really important tool for accountability. It gives producers a view of how data is used downstream. So now you can hook it up to any schema changes to check whether it is any kind of schema changes, is it impacting any downstream reports or usage. And this bridges the gap between producers and consumers that didn't really exist before. Similarly, consumers can get notified for any upstream changes that impacts them. So there you have it, folks, all 10 points. To recap, the 10 tips that I went through today: bring everybody to the one water cooler, choose a common platform agnostic schema language for everything, even for files, rows, think everything in the data world. And use schema for more than just schema. Keep the logical and physical together, but also keep them separate. Crowdsource metadata ingestion. Everything must have an owner from the beginning and meet consumers where they are. Shift left, give producers the ability to define what they are sending, and embrace data contracts. And that's it. Thank you so much.
Thank you, Sherin. That's very good. Yeah, thank you. And you're right on time. Actually, we still have 5 minutes or so. So feel free to ask questions to Sherin. Anyone have questions?
Okay. So as companies are starting to introduce LLMs into their systems, what are the places that you envision large enterprises who probably already don't do data governance very well, what do you predict they will fail at as they go to LLMs and very data-intensive new structures?
Yeah, so my hunch is, at least in this area, for structured data, it is still, it is easier to know the nature of the data, or, you can rely on people to tell you via schemas and so on and so forth, it becomes even more challenging for unstructured data. Do you know, like where is the data, where is the source of data, what is the data quality, what, does it contain any private information and so on and so forth. So what I foresee happening, and which I'm already seeing happening quite a lot, is a lot of like data quality checks and assertions and contracts are becoming more important. Ways to essentially find the nature about the data, whether, does it contain private information and so on and so forth, and also the provenance of it. Where is this information coming from? Is it, appropriately organized by that? Like, is it the context where the data originated and so on? So this is, I feel like with LLMs and all, we are going more into the unstructured data world where there are completely different set of challenging problems.
But when we look at vector databases that are essentially unknowable, what do those concepts mean with a black box like a vector database?
Yeah, that's a great question. So even with vector databases, I think it's in my opinion, it's very hard to do it at a very like granular way. For example, it's very hard to know whether an entry in there, like what is the nature of that. So my guess is, and I haven't really worked a lot with vector databases, the granularity of where governance happens might happen, at the table level. There may be certain data that you may just not store or make it available for retrieval or, in your, in the data set. So I feel like that's where it might just end up happening. Yeah.
Thank you. Yeah. Anyone else have questions for Sherin? Yeah. No? No? Okay. Yeah, I guess you can always still go up to the Q&A island up on the 4th floor to talk with Sherin too afterwards, right? If you're still around to. Yeah, okay, great.
Awesome.
All right,
Thank you, folks.
Thank you.